Hello everyone. It's my pleasure to present my current research topic, which is titled "And You Understanding the College Students' Happiness with Machine Learning and Monte Carlo Methods." My name is Isaac Caicedo Castro. I'm full professor in the Department of System Engineering at the University of Córdoba in Colombia. There are two there are another two universities of Córdoba in the world. One is in Spain and the another in Argentina. I work in the one in Colombia. I hold a PhD in informatics from the University of Grenoble-Alpes in France, and another PhD in system and computer engineering at the National University of Colombia. This is my email address. Don't hesitate to contact me if you have any question about my speech. All right, this is the schedule for my speech. First of all, I'm going to introduce the topic. Then I let you know the research methodology that I have adopted. Then I present the results of my research. Next, I analyze them. I analyze the results, and finally, I summarize the findings and present some directions for for further research. So let's start with the introduction. Have you ever paused and asked yourself, "Am I happy?" If so, have you ever wondered if your students are? And more importantly, what actually swells the happiness? Today, I want address these questions from a philosophical point of view. Instead, I'm going to present some insights revealed by the machine learning Monte Carlo methods. So, why must we pursue happiness after all? Well, happiness is the pursuit of life, according to the literature. Besides, happiness is the foundation of a better life and a goal that people pursue. According to the Oxford Dictionary, happiness is about feeling or showing pleasure or contentment with, in this context, with the university or your student life at college. Besides, happiness is about having sense of confidence or satisfaction with confidence in your in the higher education system or satisfaction with your university or college. But moreover, happiness is about how the student feel satisfied with the quality or standard of the university or of college. So, what are the key factors that shape college student happiness, and how have they been examined in prior research? Well, time management is a key factor according to prior research. Furthermore, relationship with peers is a key factor. Quality of the learning environment is an important factor as well. And of course, the student grades are important for the students to feel happy. Which machine learning methods have been most commonly used in prior research? Well, regarding supervised learning, in previous research, the author had adopted linear and logistic regression, random forest. They have also implement unsupervised learning methods like principal components analysis, k-means, and non-machine learning methods like Pearson correlation, which is more a statistics model, and averages, which is very famous in epidemiology. Which additional machine learning methods have been explored in prior research? Well, we have string gradient boosting, neural networks, k-nearest neighbors, AdaBoost, and support vector machine. These references have been implemented in countries like Thailand with 388 students. In China participated 933 responders, and in another study 2,186 responders. In Hungary, 99 students. In India, 280 students, and in another study, 2,145 responders. As a matter of fact, Colombia ranks the 61st place in the World Happiness Report. As far as I know, no private research have addressed these questions, which are how happy are system engineering students at the University of Córdoba, and what factors contribute to their happiness. So, in the next slide, I'm going to discuss the research methods that I implemented in my study. I conducted a survey of 168 students enrolled in the system engineering program at the University of Córdoba, and I selected as independent variables those factors according to the results obtained from the F-test. I scaled the independent variables in the range from 1 to 0. I implemented multi-dimensional linear regression, actually rich regression, and I use Monte Carlo simulation to calculate the odds ratios. So, which factors or independent variables I consider in the survey? First of all, grade point average. However, the p-value is greater than 0.05, so I didn't use this factor in the regression model. I also considered the number of complementary activities, such as internships, research projects with faculty, and academic workshops, and so forth. However, the p-value in this case is also greater than 0.05, so I didn't use this independent variables associated with this factor in the regression model. But I used the confidence in securing a job after graduation. Once again, as you can see, I use the Likert scale, which the range is from 1 to 5. However, I scale the value of this factor in the range from 0 to 1. And I do the same with the next following with the next factors, such as meeting with an academic advisor, peer support. The student might feel overwhelmed with the coursework. However, the p-value is related to this factor is greater than 0.05, so I didn't use it for the regression model. And the confidence in solving real-world problems based on the students' computer programming skills and the abilities to solve problems related to mathematics and physics is another factor that I consider, an independent variable that I use. Besides the passion for pursuing a degree in system engineering, the motivation to excel in studies, the financial concerns, the satisfaction with the quality of lecturers, and an adequate learning environment with up-to-date resources. In the end, the student I, or the independent variables associated to the student I, are represented by the d-dimensional vectors xi, where d in this case is equal to 9 because we have 9 components or 9 independent variables. On the other hand, the target variable is the student happiness, which is in the range from 1 to 10, when the highest level correspond to those students who are utterly happy, while the first level correspond to those students who are completely unhappy. So far, I have a data set with the tuples xi and yi, where xi represent the independent variables and yi represent the dependent or target variable. I had n tuples. Here n is equal to 134 to find the regular patterns captured by this function g, used to map the independent variables to the target variable. So g of xi must approximate to the target variable yi, and this function is a linear combination between the weights of each factor and the values of these independent variables. For future convenience, I adopt this notation using the matrix X, where each row corresponds to the independent variables associated to each respondent. And the first column, in the first column, each value is equal to 1, as you can see here, to compute or to calculate the intercept value in the linear combination W0. So W is a vector whose components are the weights of the regression model, while Y is an n-dimensional vector where its components are those values in the data set. So we have here the matrix X, which is a n times d plus 1 dimensional matrix, and W is a d plus 1 dimensional vector in a real value Euclidean space, and Y is an n dimensional vector. As I mentioned before, our goal is to find W that minimize this objective function, where lambda is the regularization parameter used to prevent overfitting. And the solution to this optimization problem is W, as you can see here. Doing some math, we found the equation that you can see in this slide, the last equation. So I implemented tenfold cross validation to find the best regularization parameters. To this end, I use 134 tuples for the training data set, for the cross validation data set. Well, I use 34 variables, tuples, to test the G function, the G prediction function. I measure the quality of the prediction using the coefficient of determination R squared and the root mean square error. Then with the prediction function, I compute the conditional probability that the student I is happy. In this case, I consider that a student is happy as long as the target variable is greater than 5. While I consider that the factor J exert influence in the student happiness if its value is greater or equal to 0.7. So this conditional probability is the probability that the student feels happy given that the factor J exerts influence, and is calculated by integrating the joint probability between both events, normalized by the probability that the factor J exerts an influence over the independent space, independent variable space, as you can see here. In a similar way, I compute the conditional probability that the student feels happy although the factor J exerts no influence in this event by integrating over the independent variable space the joint probability that the student feels happy while the factor J exerts no influence in this event, over the probability that the factor J exerts not influence in the student happiness. To this end, I generate n random vectors such that each component is in the range from 0 to 1. To you understand the Monte Carlo method that I employed, let's consider this function 1 of u, which is equal to 1 as long as u is true. Otherwise, 1 of u is equal to 0. So the conditional probability that the student feels happy given that the factor J exerts influence is approximated to the number of cases where the prediction function is greater than 5 and the factor, the independent variable J is greater than 0.7, divided by the number of cases where the independent variable is greater to 0.7. On the other hand, the probability that the student I feels happy given that the factor J exerts no influence is approximated to the number of cases where the prediction function is greater than 5 and the factor J is less or equal to 0.3, divided by the number of cases where the factor J is less or equal to 0.3. So the odds ratio is this fraction where the numerator, as you can see, is the ratio of the conditional probability divided by the complement, by its complement, and it happens the same in the denominator of this ratio. As you can see, is conditional probability that the student feels happy given that the student the factor J exerts not influence, divided by its complementary probability. Well, now I present the results of the simulation, and this is this histogram illustrates that the most frequent answer of the responders of the survey is that they feel in the 7th level of happiness, as you can see here, considering the training data set, and it's similar to the test data set. The only difference is that the next probability level is the 5th level. but the distribution of the data are similar in both cases, in the training data set and the test data set. From the 10 forecast validations, we have found the best average root mean square error is equal to 1.38, which is a very small value. This suggests that the regression model is a good predictor. And the best mean of coefficient of determination from the obtained from the 10 forecast validation is equal to 0.23, which is better than using the mean as a predictor. But these results are far better. These results correspond to the evaluation of the prediction function G. And the outcome of the test revealed that the root mean square error is equal to 1.09, which is a very small value. And the coefficient of determination is 0.56, which is much better than using the mean as a predictor, and is even better than the outcomes we obtained from the 10 forecast validation, as we saw in the previous slide. And this is the linear combination of the function G, the prediction function G. And as you can see here, the greatest weights correspond to the factors such as the satisfaction with the quality of the lecturers and an adequate learning environment with up-to-date resources. These factors exert a strong influence in the student happiness. On the other hand, the financial concerns exert a negative influence in the student happiness, as you can see here in the regression model regarding its weight. From the Monte Carlo simulation, we use more than 52,000 random vectors to find that the expected happiness level is roughly 6, which is a very low standard error, and the expected value of happiness, student happiness, is within a narrow interval with 95% of confidence. This chart illustrates how the Monte Carlo simulation converges to the solution as n increases. And we have found, as I mentioned before, that the most probable level is the 6th level, and the next one is the 5th one, following by the 7th level. This histogram shows the same outcomes that we saw in the previous slide. And these are the odds ratios calculated from the results obtained from the Monte Carlo simulation, where satisfaction with the quality of lecturers is a key factor, and the next one is the access to up-to-date resources, while the financial concerns exerts a negative influence in the student happiness that we saw with the function G resulting from the regression model. So this chart is another way to present the aforementioned outcomes in the previous slide. And you can see here as well that the satisfaction with the quality of lecturers is a key factor, and the next one is the access to up-to-date resources. And the following influential factors are the confidence in securing a job after graduation, the peer support, the passion for pursuing the bachelor's degree in system engineering, the confidence in solving real world problems, and the less influential factor is the motivation to excel in studies, while the financial concerns exert a negative influence in the student happiness. All of this is revealed by this forest plot. Well, now I'm going to analyze these results, and perhaps the strong influences of the lecture quality might be explained because of the social support is quite important to foster the student happiness according to the literature. But also I might say also that the lecturers are those that are in charge of increase the positive, engaging, and supportive learning environment. They must guarantee this kind of environment. Empathetic lecturers might foster the hopes about the future in the students. Poor lecturers increase the confusion, and the confusion increases the stress and the anxiety. While high quality instruction makes the student feel that they are spending the time, money, and effort properly. As a strategies, I propose continuous development for lecturers. The lecturers must provide the student with constructive feedbacks about their work. The lecturers, the university must promote a student-lecturer interaction, and the staff and lecturers must align the lessons with the student needs, while the college and the university should reward those teachers that excels in their work. We know that up-to-date resources is a key factor, because this boosts the motivation. This improve the student perception of quality. With the up-to-date resources, we might obtain better learning outcomes, and this reduces the student stress. This fosters engaging classroom discussions and aligns with tech-savvy expectations. I propose some strategies such as both staff and lecturers must provide the students with visuals, videos, lecture notes, books, and so forth. And the university must provide the student with decent facilities, sport fields and gyms for recreation and improve their health. They need good illumination and good temperature in the classrooms, and access to the cloud and good power computing. Perhaps, maybe in the foreseeable future, quantum computers. The sense of security, purpose, and future well-being might explain why confidence in securing a job after graduation is a key factor to pursue happiness. Besides, the endeavor of the student is somehow meaningful. If they had confidence that they can attain a good job after graduation. So studying in this case is not a risk, but it's an investment. Confidence in securing a job actually reduces the uncertainty in the future and increases the motivation and engagement. enhance the students' self-esteem, and allows them to perceive a financial stability in the future, and reduces the pressures, the social and cultural pressure. I propose these strategies like introduce a career planning from the first semester instead of waiting for the last semester. Moreover, I propose to provide the student with information about employment trends, salary expectations, which are the growing sectors in their environment and in other countries. Whenever it's possible, to include internships in the curriculum, adopting the project-based learning and case studies to improve the communication skills, the students' problem-solving abilities, to foster the teamwork, and to battle the digital literacy. Besides, I propose to teach the student how to use professional platforms like LinkedIn, so they can increase the odds for finding a decent job after graduation. Regarding the financial concerns, these might cause mental health issues such as chronic anxiety and depression. This affects the sleep quality and the concentration and the performance during the classes. The financial concerns are a cognitive burden and a distraction for the student. They have to work to obtain money, so they have no time for improve their skills or the competencies they need in their studies. So they have less time for social life and self-care. They have no time to do exercise or resting properly. This reduces the academic opportunities, like attending events in other cities or in other countries. Furthermore, they feel fear for the future because it's uncertain, and this might cause dropouts and delay graduation. The University of Cordoba have implemented some strategies like waiver the enrollment fees for undergraduate students. They also provide the students with grants to conduct their research. The well-being department provides the student with counseling services to fight the mental health issues in the student community, and the library at the University of Cordoba possesses a good collection of online and printed literature. Furthermore, the university has agreements with the public transportation service to reduce the cost of the transportations for the students. So I summarize on the findings of the study and outline some directions for further research. So far we have found that the satisfaction with the quality of lectures is a relevant factor. The odds of a student being happy are 11.37 times higher if they perceive the lecturers to be of good quality. Besides, it's important that the student have access to up-to-date resources, confidence in securing a job after graduation. They need peer support or classmate support. The lecturers and the university in general should guarantee that the students attain passion for pursuing the bachelor's degree in system engineering. The lecturer must work in the skills for solving real world problems, in the student skills for solving real world problems, and the motivation to excel in studies. Besides, it's quite important to guarantee that the student can hold meetings with an academic advisor to improve the odds for attaining happiness. The university must find strategies to cope with the financial concerns of the students. As a directions for further research, I propose I collect more data to draw better conclusions, to study other factors that exert influence in the student happiness. I assume nonlinear relation among variables. Therefore, I adopt Gaussian processes for regression and kernel ridge regressions and other machine learning methods. I create and evaluate a feasible and a realistic strategy plan besides policies to help the student to pursue happiness. I analyze the latent factor that is playing the observable factors, and taking into account that the peer support is relevant for the students to attain happiness. I conduct research to analyze the student social networks. Well, if you have any question, please don't hesitate to email me and keep in touch with me. Thank you very much for your attention. That's all, folks.